Okay, so there are 10 questions in this quick revision for amath indices. So I'll be showing you some samples. Basically, it is using indices, but in a backwards manner. Okay, so the main two indices rule that we use in the backward manner are the same-base multiplication. So in emath, so when we see same-base multiplication, we will add the power. And when we see same-base division, we will subtract the power. So that is the focus. That is the main thing about this rule. But in this amath indices, a lot of times you need to work backwards. So you need to relate that when we add, it actually comes from a multiplication. When we subtract, it actually comes from division. So if you couldn't twist this, then you will have a lot of issues. So it's a working backwards of these two rules. Of course, other main rules will be the double power. So the double power rule is also quite common. Um, uh, the rest of the rules will still be applicable. It's just that these are the few more frequent ones. Okay, so I will show you a few samples, then you will be trying to complete the whole thing. So for example, question one, okay, it's a very typical question. Like they will give you a whole expression. They wanted you to explain or show why the whole expression can be divisible by 15. Okay, so in this question, whatever they want you to divide by, you in the end you must simplify the whole expression until you get 15 something. You must have 15 as one of the factor. It can also be 30. Okay, so as long as you can get a multiple of 15 in the final answer, then you will be able to show that it is exactly divisible by 15. Okay, so I will show the whole question of this. Okay, so the expression, they learn to recognize when can you split the power. Okay, okay. Before I show you the splitting of power, I need to show you a common mistake first. So a lot of time, a lot of students will do this for this question. A lot of students will, when they see this, they will go and do this. So it's a very common mistake. It is not correct. Okay, why is it not correct? Because if you think about this, it's something like this. So the base is different, the power is also different. You cannot be multiplying anything when the base is different or when the power is different. You only get to do something when you have same base, then you can do something. Or when you have same power, then you can do something. So in what situation will you get 6n? So the correct thinking will be if you got 3n and you got 2n, and because both are the same power, then that is a situation where you will get this. So that's one of the common mistakes that a lot of people will do. So in this case, for that's just a sidetrack first. So I will come back to this question. So now I'm going to look at the addition here. So there's the addition of power. It will come from a multiplication. So the second term, I'm going to leave it there. Here, there's also another plus, meaning that it will come to a multiplication. So you will get 2, 2n, 3, 2n, and here you will have this. So in the end, oh, sorry, I write wrongly. So this one should be power n. So 4 times 4 will be a 16. I keep writing the wrong thing. So this one is n. Okay, so at this point, there's nothing you can do already because there's no power for you to break. So you can continue from here. If you are the kind who works better with substitution, then you can think of it as like 2k minus 3k plus 16k. So you can think in this way. So if you do a 2k minus 3k plus 16k, then you will get a 15k. So you can think in substitution idea, or you can directly do a 15, 2n. So you get a multiple of 15. So what you can explain is the expression has a factor of 15. Therefore, it is exactly divisible by 15. So if let's say you happen to get 30 something, is it also divisible by 15? Yes, because you can always divide 30 by 15. Okay, so you can try on 1B, it will be the same idea. So in 1B, you're supposed to make it divisible by 19. So in the end, right, you should be getting something like 19 bracket. So you give it a try. Okay, another category of question is when they will give you a chain of indices, then they ask you to evaluate. So the idea of evaluate means you are supposed to find the final value. So evaluate means you find the value of 6 power x. Usually you're not allowed to find the value of x, and it's really not possible for you to find the value of x. Okay, so in such a case, okay, the approach will be something like this. You look at the indices given to you first. Okay, try to make the base small. So make small base. So what are the base that I would like? I would like the base to be prime number, because you cannot reduce prime number anymore. So we try to make smaller base. Okay, but in this case, if you look, 3 is already a prime number, 2 is already a prime number, 3 is also a prime number. However, 4 can change to 2 square. So once you already make the base as small as you can, follow the steps. The next thing is you put them into same base on each side. It doesn't matter which side. So for example, so in this question, I got base 2, I got base 3. I'm just going to put them on different side. Okay, so how do I put them on different side? You divide over. So you divide over. So this one, I will divide over. When you divide over, you are doing same base division. You are doing same base division. So it's equivalent to doing this. So you just directly subtract the power. So you will do a same base division. So be careful when you subtract the power. Subtract with bracket. So a lot of students may make some mistake here. So from here, you work out your algebra. Work out very carefully. Be careful of your sign error. Okay, sorry, I write wrong thing. This one is base 2. So once I put them onto the same family already and I apply the same base division, okay, then now I'm going to do the backwards. So when it is a plus, I'm going to break it out to a multiply. When it is a subtraction, I'm going to break it out into a divide. So in this case, it will be a divide on this side. Then there will be a multiplication on this side. then you can think about it as a cross multiplication. So you can see it as a cross multiplication. And if you look carefully, these two have the same power, meaning you can multiply them. And from here, you will get 6x equal to 9 over 4. So you will be able to find the value without finding x, but sometimes the question will extend. They will extend to you to find the value of x. So you can apply your LG both sides. So there are two methods after this. So I show you the two methods. So for me, I prefer to, so if you're asked to find the value of x, so for me, I like to take LG or LN on both sides. So I will do a LG on both sides. Then that will allow me to bring down the power. Then I just divide. So that's my method. So there's another method that some students prefer. Some students prefer to change it back to logarithm format. So some students will change like this. They will change it this way. So if you are the kind who change it this way, it's fine. But you need to do a change of base. You still need to do a change of base because otherwise you cannot punch out on your calculator. You are required to give the value of x to 3SF. So you got to do a change of base. So usually we'll change it to base 10 because that will allow me to punch in the calculator. So eventually I will get the same answer. So it's up to you which one you prefer. Personally, I use method 1. Some of you may be using method 2. So whatever method, you will end up as the same answer. So the general steps will be when you see an expression like this type of question. Okay, let's run through the steps first. Your job is to make small base. Make sure you make the base as small as possible. So the smallest will be prime number. And then after that, you put the same base on each side. So one base on each side. Okay, so it's like you separate them. Then subsequently, when you do that, you should be applying same base division most of the time. And after that, your job is to split. So your job is to split. So if you take a look here, I split. So I got to apply the backwards of this of indices so that I can cross multiply and eventually I will get the values. Okay, so you can try this idea. The steps are standard. It's a very standard step. So you can try the standard steps on the next 3 questions. It's really very standard. Follow the method, like then you will find that most of the time you are able to do this kind of question. Okay, and then there's also some other kind of question that will also use the reverse of the indices. So I'm going to give you an example. Okay, so maybe I'll give you an example for okay, maybe I'll give you an example for question 7. Okay, so for the same thing, there will also be you need to split the power. So if there's an addition in the power, you need to split. However, you still need to try to simplify the base. So for example, here, I realized that 25 is 5 squared. So I can do it this way. And here, because it's already a prime base, I'm going to split. So I'm going to do like this. You can do it like this, or you can do it like this. Okay, so it's the same thing. Or you can actually do it this way. It's up to you. So if you do it this way, you must remember that this is actually a 1/5. Okay, so it's up to you how you want to do it. So I can do it as a divide. Okay, then I'm going to split the plus here. The plus here means it will be a multiply. So this whole thing is divided by 5. That means that I'm getting a 1/5. And do you realize this one has the same power? So the bottom part, I managed to simplify until I got a 15. The top part, I also got this part here. This part here got the same power. And this is a 25. So I got 25. I got a 3 times 5. Okay, do you realize I leave the 15 2x alone? So I got 25, 15 2x, and I got 15 2x, and then I got a 1/5 15 2x. So again, what can you do from here? If you are the kind who substitution works for you, you can think like substitution. You can think like substitution. You got 25k plus k, and you got 1/5 k. So you end up with 36k over 1/5 k. So you can think this way. If you think this way, you end up with 36 15 2x divide by 1/5 15 2x. And then you just punch calculator. So sometimes substitution can help you to facilitate the working. So there's quite a few of this category of question. These are the variety that's more amath indices than emath indices. So do go and try it out.